Welcome to Communication Engineering playlist. Here in this session, I'll be explaining Foster Seeley phase discriminator, and that is what we are deal with to use it to have FM demodulation. Now, I suggest you to see my previous videos where I have explained how we can have basic FM demodulation. Then this session will be easier to understand. Now, basically we have already seen in previous session, like when we do FM demodulation, all we do is we just pass this signal of FM modulated signal through differentiator circuit, and then after we pass it through envelope detector. And then we extract modulating signal out of that. So what happens is here our input signal will be FM modulated signal, and then after we'll be having signal which is what phi of AM, that is what somewhat similar to amplitude modulated signal, and over here we have message signal. Now if you see my previous session where I have explained frequency discriminator, and in that we use tuned amplifier over here. So in phase discriminator even we will be using tuned amplifier here, and in that tuned amplifier what we will be doing is we'll be having phase difference calculation at output side to have amplitude. So here we will be using phase difference to have a calculation of phi of AM. That's why this Foster Seeley phase discriminator, that is what actually based on phase difference calculation. So that's why it is even referred as phase discriminator. So this is what I'll be explaining in this session. So let us move further to the basic circuit diagram. Now here one can see this is what the basic diagram which is there with Foster Seeley phase discriminator, and in that basic diagram you will be finding there are three difference which is there with respect to frequency discriminator. One basic difference, that is we connect this capacitor over here. So this is one difference. Second is when you see this inductor, so single inductor that we are using over here, and this single inductor, that is what center tapped over here, and that is what we are connecting here. And third basic difference, that is what this inductor that we connect here. So that is how the basic difference that you can identify in this phase discriminator compared to frequency discriminator, which we have seen in balance demodulation using frequency discriminator. So these are the basic difference which is there in that circuit. Now when we talk about its working, then basically this circuit that is functioning as tuned amplifier. So this circuit that is functioning as tuned amplifier. Now this circuit that will be resulting into phi of AM signal over here, where here one can see two slope detections are there. So these two are two slope detection which we can observe here. And when we talk about its working, then its working is purely based on phase difference, where if you see this capacitor, so this capacitor provide out of phase polarity to this voltage V1 and V2. So here in its working, this is very essential to understand this V1 voltage and V2 voltage that is out of phase, and that one can observe, like see this capacitor is connected in between these two terminal. So V1 and V2 voltage, these are out of phase voltages. So let us mention it first. V1 and V2 are out of phase to each other. Now its working is purely based on what will be the voltage which is there at VA1 and VA2, and as per that we'll be having output V01 and V02. Basically our output, that is what based on difference of these two voltages. So our output voltage, that is V0, so that will be mode of V02 minus mode of V01. That is how our output will appear. Now let us calculate what will be the voltage which is there at VA1 and VA2. Now see, as I have told, V1 and V2 both are out of phase to each other, and V3, that is what voltage across inductor. So VA1, that will be voltage, that is what V3 plus V1. So here VA1 voltage, that is V3 plus V1. And when we talk about this VA2 voltage, so that will be this V3 minus V2 voltage. The reason is V2, that is what out of phase to V1. So obviously it will be having opposite phases with respect to V1. So V2 will be, VA2, that will be V3 minus V2. So this VA2, that will be V3 minus V2. So let us have again quick review again. See, V output voltage, that is what difference of V02 minus V01. Second is what is VA1, that is V3 plus V1, and VA2, that is V3 minus V2. And V1 and V2 both are out of phase to each other. This is what tuned amplifier, and that tuned amplifier gives voltage with respect to input frequency. So to understand its working, I'll explain, like there are three cases that I'll be explaining. Based on that you can understand like how voltage is at VA1 and VA2 is appearing. But before that we need to understand V0 is what V2 minus V1, and that VA1 that we can calculate as per V3 plus V1, and VA2 that we can calculate as per V3 plus V2. Now there are three cases which I'll be explaining, but before that let us see the characteristic of tuned amplifier. So if we see the response of tuned amplifier, then that response that will appear like this, where its center, that is what tuned at FC frequency, and if I say deviation over here, then that will be having frequency FC minus delta F, and over here that will be FC plus delta F. That is how deviation is happening. Now what if our input signal that is tuned at frequency FC? What if our input FM that is tuned at FC plus delta F? And third case is what if our input that is tuned at FC minus delta F? So if I say first case where our input that is what at resonance, as per this is what maximum amplitude, so that is what resonance. So at resonance FM is tuned at frequency FC. So as if FM is tuned at frequency FC, this V3 voltage that will be with 90-degree phase with V1 and V2, and V1 and V2 both are out of phase to each other. So when you calculate VA1, so VA1 is what? Voltage in between V3 and V1, so that will be this, and VA2, that will be voltage in between V3 and V2, so that will be this. So that is what VA2. Now if you observe over here, this V3, that is what 90-degree apart to V1 and V2, so VA1 is equals to VA2 over here. So VA1 that is equals to VA2. So as VA1 is equals to VA2, our output voltage, that is what difference of V02 minus V01. So what will happen is our output voltage, that is V01 minus V02, and as both voltages are same over here, this output, that is what V02 minus V01, that will get to 0. So our output will be 0 in this case. Now let us consider second case, that is what? At off resonance. Now see, at off resonance, this tuned amplifier circuit that will give different phase at V1 with respect to V3 and V2 with respect to V3. Now at off resonance, if I consider Fc plus delta F, so in that case, phase at Fc plus delta F, phase in between V3 and V1 will decrease and phase in between V3 and V2 will increase. So let us try to understand how it will increase and decrease. So for that, if I say this is my V3, and as I have told, phase in between V3 and V1 will decrease. So over here, this is how it will decrease. This is V1, and as V1 and V2 that is out of phase, this phase that will increase. So when we calculate VA1, that is this which is in between V1 and V3, and this is what VA2, that is in between V2 and V3. So obviously VA2 that will be greater than VA1. So over here in this case, VA1 that is less than VA2, and as we know our output, that is V0, that is V0, that is V02 minus V01. So as VA2 is greater than VA1, one can see this is what greater than this, so our output that will be positive voltage. One can consider one example, like see, if this is 60 degree, then obviously this has to be 120 degree. So this VA2 that will be greater than VA1, and as our output, that is what V02 minus V01 at frequency Fc plus delta F, means at this frequency output will be positive. Now let us consider third case, in which our FM signal that is tuned at Fc minus delta F, and if FM signal is tuned at frequency Fc minus delta F, phase in between V2 and V3 that will be lower than the phase in between V1 and V3. So what will happen is, if I plot phasor diagram, then this is what my V3. Now as I have told, phase in between V2 and V3 that will decrease, and this is what V1. So if you see voltage in between V3 and V1, that is what VA1, and voltage in between V3 and V2, that is VA2. So obviously VA2 that is less than VA1. So in this case VA2 that is less than VA1, and as our output, that is what V02 minus V01, one can see this VA2 is less than VA1, so this value that has to be negative. So that is how amplitude that will change at output side as frequency is getting changed, and we can be able to extract original information. So at the end you will be finding over here, you will be getting modulated signal. Now let us try to understand that with respect to phase diagram. So over here, if I say the characteristic of VA1, then you will be finding characteristic of VA1 like that, and if you see characteristic of VA2, so you will be finding its characteristic is like that. This is what VA2. Now if you see frequency, then frequency over here that will be Fc, and let us say frequency over here, so that will be Fc plus delta F, and frequency over here that will be Fc minus delta F. Now in this case, if I consider tuned frequency FC. So in that case, VA1 that is equals to VA2. So in this case, our output V0 will be 0. The reason is it is what? V02 minus V01. Now if I consider second case, that is FC plus delta F. So that is having these 2 points, and in these 2 points one can see VA2 is greater than VA1. So in that case, our output, that is what? V02 minus V01, as this is greater than this, we will be finding positive voltage at output side. And at third case, FC minus delta F, there is these points. So in that case, one can clearly see here VA1 is greater than VA2. So as our output is V02 minus V01, our output over here, that will be negative. So that is how output is appearing with respect to tuning frequency. So that is how we do phase discrimination and we extract output signal. Now let us focus on some advantages and disadvantages. So first advantage is it offers good level of performance and resonance linearity. So in this zone, it is what useful zone of frequency where it offers very good linearity, and that linearity could be utilized to extract modulating signal. Second is it is easy to construct by discrete component. Here by using inductor and capacitor we construct this circuit. So we can easily construct this circuit by using this discrete component, inductor and capacitor. Now let us see on few drawbacks. So when we talk about drawbacks, it is not suitable for IC technology. See, this Foster Seeley demodulation technique that have been introduced in 1936, and when IC technology came in 1970, IC technology came. So at that time this circuit was not compatible with IC technology, so we were not been able to use this with IC technology. Second is here we use tuned amplifier LC discrete component, so this circuit is costly. And third, that is what major disadvantage, that is noise granularity. Now how things are happening is like, see, we have Y of FM, and when you pass it through tuned amplifier you will be having phi of AM. Now when you have this, at the time it introduces some amplitude noise, so it has noise granularity, and to remove that we need band pass limiter. So to remove this we need band pass limiter. So it has amplitude noise because of when we translate that by tuned amplifier from Y of FM to phi of AM, it introduces some amplitude noise. So we need to have band pass limiter at this end, and that is where some amplitude noise is getting introduced. So this drawback we can resolve in next technique, so that I'll explain you phase detector, where I'll be explaining like, see, how we can remove this disadvantage. So stay tuned with this channel. In next session you will be finding phase detector with phase discrimination method. Thank you so much for watching this video. You can give me your valuable suggestions. Your suggestions are most welcome to me, and based on that there will be few more sessions based on analog communication. Thank you so much for watching this video.